push that over. Okay, so as I've mentioned, the RDARI working group created a survey, which is intended to be a global survey of institutions, particularly universities, but we've got some other researching institutions contributing it to as well. It was quite a long survey. Having said that, despite the length and the slightly repetitive nature of some of the questions, we did manage to get 82 complete responses in the end, after a bit of deduplication and disqualifying some people who were just talking at the departmental level or faculty level rather than representing the entire institution. Some of you will doubtless have been in the design of this, because we did go through a couple of plenaries trying to really craft what the questions should be, what people could reasonably be expected to answer, and the kind of information we got. So it was quite a rich record in the end of the current state of the art. The idea of the survey was that it would be useful for benchmarking purposes between universities. You could see how your friends and rivals were doing. But we also designed it as a way to get in touch with people at other institutions who might be doing similar things than what you're planning on your own institution, applying the similar kinds of technologies. So you could actually get in touch with people and discuss things further and compare notes. So it's still a very relevant survey, I think, and the DOI is down there. I will put it in the chat a bit later. But obviously, it's an RDA survey, so it's completely open, and you can take it and reuse it as you choose. And do please take a look at it and get in touch with anyone you want to from it. So I mentioned that one of the services we looked at was electronic lab notebooks. We actually asked a formal set of questions about these specific services in the end. This kind of introductory slide is really the number of institutions that responded who already have particular RDM services, or who are developing them at the moment. So there's perhaps no great surprise that live research data storage was a service operated, provided by many institutions, a research data repository where people could access records and data of published data sets, an advisory service, backup services, and data management planning services were all quite common across their various different institutions. Looking down the list a little bit further, electronic lab notebook services are still in a bit of a minority. So slightly more than a fifth of institutions who responded to the survey already have an ELN service in place. And a fair few other institutions were in the process of working on them at the time. So I'll talk through what we found from the responses and a little bit about what the future might hold. So we asked a number of questions about ELNs. Obviously, we're talking about a smaller number of responses now. So this is only about 15 to 20 or so responses here. So don't take these statistics as necessarily entirely representative of the global community, but it's what we got. So most people who've already set up an ELN are supplying it externally. They're using one of the providers, one of the many providers that currently offer these things. There's a couple of institutions that have developed something in-house. Of the software that people had brought in, of the solutions people have brought in, Lab Archives was the single most commonly used one. RSpace was also popular, and there were a few other names down there. Most people who responded were quite happy with the solutions that they're offering. There was only one, I mean, because we're talking low numbers here, that red segment on would you recommend the solution you chose to others, that actually only represents one vote. They were a user of Lab Archives, but the other users of Lab Archives were all very happy with the product, so I don't think we read too much into that. In terms of the uptake of central electronic lab notebook services within institutions, most respondents only had between sort of about 0 and 20% of their researchers actually using them. But do bear in mind that most of the respondents to the surveys were working in big multidisciplinary universities. And in such an environment, you wouldn't necessarily expect everyone in the humanities and social sciences, for instance, to be adopting any centrally provided electronic lab notebook. I think the one institute that did report that over 90% was using this was very much a discipline-specific institution where you have a little bit more control over who actually uses these things. If you can dictate that people ought to use them, it's a lot better than simply providing something and hoping that people might pick them up. Sorry, to move the window around a bit so I can see my slide. So a clear majority of institutions were paying for their electronic lab notebooks out of their general institutional budget, and were offering them free at the point of use to the end users. There's a couple of institutions that expected their researchers to cover the costs, and one that was using a mixture of institutional and grant funding. But those are basically what we could conclude from the survey. That was done between July and November 2019. Since then, of course, the situation facing researchers, particularly researchers who are working in laboratories, has changed somewhat. So whilst we haven't run a second RDARI survey yet, what we did do within my own institution, University College London, we did a survey of our own researchers to see whether they were already using electronic lab notebooks, or whether they were traditionalists sticking with paper lab notebooks for the time being. And this survey was actually run earlier this year, so between March and May, which is really the point at which, certainly in England, the first major lockdown was taking place, and people were having to find different approaches to doing experimental science in particular. One of the things we actually found was that the use of electronic lab notebooks wasn't quite as limited to the kind of faculties that we thought it might be. So the chart on your left-hand side there looks at the different faculties across the university, and the sorry, wrestling the video, that's better. As you can see, it covers all the different note-taking possibilities that people were using in the different faculties. The colours to pay attention to are the kind of golden yellow, which is people who report that they record their research processes and notes using paper-based lab notebooks, and the smaller green one. So as you can see, within each faculty, only a small proportion of researchers are actually using electronic lab notebooks during the second quarter of the year. And if you just take out the researchers across the institution that are using some kind of formal lab notebook, still a large majority were using paper lab notebooks over electronic lab notebooks. We expect that to change a bit, I think it's fair to say. So we also asked people whether they were interested in using an electronic lab notebook that we could provide centrally as an institution. And the interesting thing is, across a whole wide range of faculty, we actually call it an electronic lab notebook or electronic research notebook, because of course the terminology can be rather alienating. But a lot of people were very keen on the idea of using a centrally managed service. Some perhaps slightly more sensibly said maybe, depending on how well it fits their particular need. But there was quite a lot of enthusiasm, and I strongly suspect that it was brought on to a large degree by people realizing that if they had a paper lab notebook and they can no longer access their laboratory, the paper lab notebook was not very useful. So I think we're seeing a growing interest. But our institutional ELN's the right way to go. So this is one of the questions that we're going to be looking at in this session today. Does it actually make more sense to run a kind of unified ELN system at a larger scale, to allow individual researchers simply to choose the solution that they feel is going to be best for them? As an institution, if you offer an institutional ELN, can you add any real benefit, add any real value to what people might get if they're using ELNs just on a sort of personal lab group basis? Can they be integrated into the sort of the overarching architecture of research-based services in institutions to add value? Is there anything beyond the economies of scale? So on that note, I'm going to stop presenting, if I can manage that, and hand over to the first of the speakers that we have lined up this evening, this afternoon, morning, middle of the night, depending on where you are, which is Al Downey. So Al, if you want to share your screen.
So I have nothing to share, in fact. I was just going to talk without slides, if that's all right. It seems more informal and a bit more engaging. So yeah, thank you very much. I work in the Gurdon Institute in the University of Cambridge, where we study cancer biology and developmental biology. And I'm the head of IT in that institute. And my job is to spend a lot of money to provide world-class infrastructure and services to keep our scientists working right at the very leading edge of science. And so I'm sure you can imagine my exasperation whenever I see that so many of our researchers are still using pencils and paper and sticky tape to document their work. But at least they're looking after them well, filing them on the shelf between the Bunsen burners and the sulfuric acid. So we've been interested in electronic lab notebooks for maybe about 5 years now. And at first I thought it would be an easy project and a very quick win that everyone would welcome, because it seems like such a no-brainer that everyone knows the benefits of digital notebooks. I think even the most hipster among us who import special Italian pencils to write in handcrafted journals, they all understand the benefits that paper can't provide. But 5 years later, progress seems to have been slow. We did a survey, just as an aside, we did a survey in 2017, the results of which look very, very similar to what James has just reported. Not much uptake. There's a lot of interest. Many people want to switch, but there isn't much uptake. And so that's what we've been interested in. We have been seeing some progress, but perhaps not in the direction that we would prefer. We're seeing a lot of individuals independently switching and coming up with their own solutions. We've seen some DIY systems evolving within some research groups, but not many groups are switching to commercial products in any kind of coordinated way. And we've done some work in Cambridge to try and understand what those obstacles are, why we're not seeing more uptake at departmental or institutional level. And there seem to be two main reasons. The first is simply that it's not a small undertaking in terms of cost or significance or the effort involved. It's with all the other demands on a PI's time, the prospect of taking on a project that requires that kind of commitment and which will cause that sort of disruption is enough to make most people procrastinate. And we found that when we did a trial in Cambridge a few years back, where many people put their hands up to participate in the trial, whenever they realized how much commitment was going to be required. And it's not the sort of thing that you can just stick your toe in the water and learn about. You really have to dive all the way in. Many of those who were very enthusiastic at the point of signing up did not follow through with the trial because of the disruption that would be implied in their lab. So the second reason is that there are simply loads of products to choose from. More than 100 at the last count, I think. And they all seek to differentiate themselves by adding more specialist and more discipline-specific features. And I think that rather than making their products more attractive, they're in fact making them more difficult to select. In most research departments, in most research groups even, the diversity of interests and workflows that we find makes it very difficult to identify a single product that's going to please everyone. In the Gurdon Institute, for example, there are wet bench scientists working alongside computational biologists and medics and many others, and they all have very different needs. So those seem to be the two main reasons why most larger research groups and departments are choosing not to deploy digital notebook products. And we've been wondering how to get past these obstacles. And I think there's a better way that James hinted at earlier, that rather than trying to find a single holy grail product that will do everything and please everyone, a better approach would be to build a modular research notebook system, something that at entry level is as close as possible to being a simple equivalent to a paper notebook, something that's utterly basic but undeniably useful for everyone in all disciplines, in arts and humanities and sciences. And just as an aside again, with that in mind, we've started referring them to them as electronic research notebooks now, rather than electronic lab notebooks, just simply to recognize that not all research takes place in laboratories. So a completely basic notebook platform for everyone, but within that package, there would be a menu of bolt-on options that would enable researchers to switch on all of the specialist interfaces and discipline-specific tools that they need to suit their individual workflows. And because these would just be skins over a very complex underlying database, researchers would be able to switch those interface modules on and off as they wish without risk of damaging their content and without any anxiety about choosing the wrong product. So, and that seems to have been one of the things that's been holding back individuals, is the awareness that because it takes a huge commitment to buy into a system, use it for a couple of months to establish if it's the right system or not. At that point, disengagement becomes a real problem for many people. And I think they saw that, and it gives them cold feet, and they choose just not to, or at least to push it further down the road. So that's one of the benefits I'm imagining, is that a system like this would cater for every individual's specialist interests and needs in every discipline. But there are many other benefits that spring to mind as well. It would completely democratize access and create a common environment and a shared culture and a language for everyone. It would improve collaboration opportunities. It gives us an opportunity to use ORCID logins that would ensure continuity of access while researchers move around between institutions. It could create a framework for very rapid deployment of other innovations and tools to the entire academic community very quickly. Not to mention, as James referred to earlier, the economy of scale, the reduction of local complexity, local support requirements. And another benefit that I'm particularly interested in is that, given that an amount of data storage capacity is an essential feature of any research notebook system, a project like this could become the foundation of a much larger national research data management platform. Something that would enable persistent identifiers to be applied to all data sets, binding data and the documentation together. So people might be concerned about losing choice or being locked into a single system that would stagnate after it had been launched. But my view is that if it's been designed well, then I think the opposite would be true. Some or all of these bolt-on modules could be developed by commercial partners, the same vendors that are currently offering products out on the market, RSpace, Lab Archives, all these popular tools, and their commercial interests would drive healthy development. I think the products would be much more lightweight. There would be some adjustment to be made, but they would become immediately visible to the entire research community, who'd be able to experiment with trial versions before choosing to subscribe to those commercial bolt-ons, for example. And without any of the anxiety of about the pain of disengagement. If they didn't like it, they could simply switch it off and try something else instead, confident that their underlying data, underlying content would be intact. So it seems like a win-win for me, to me rather, that vendors get increased exposure and uptake, and researchers get increased flexibility and frictionless access to all of these tools. So who would build it? My feeling is that it should definitely be owned, designed, owned, operated by the academic research community and independent of any single institution. And it should be offered as a national service or an international service. In the UK, I think JISC would be the perfect organisation to deliver it. I know that JISC are represented in the list of participants here. Hello, Chris. And JISC do have some history of development of large infrastructure systems, but right now, and I think perhaps understandably in the current circumstances, it seems like there's less appetite for building big things, and the trend is to instead think in short-term cycles and to solve problems by brokering good deals for ready-made solutions. I think that's a bit of a shame because it does stifle innovation and big ideas. Nevertheless, I think it's worth pursuing, and my focus will be to continue lobbying JISC in the hope of persuading them to explore this fully and maybe even allocate some resource for a scoping exercise. I have my fingers crossed. Just today, in fact, I heard some encouraging news about a new JISC digital research community that's been created, which may become an ideal forum for discussion of stuff like this. I'll be knocking on that door very soon. So that's all I have to say, really. Is, yeah, well, thank you for listening. If any of this has struck a chord, I'd be very pleased to carry on chatting about it. about how we might develop the idea further or how we could push it forwards. And I'd be very grateful for suggestions about other groups or organisations that might become involved. Thank you very much, and enjoy the rest of the talks.
Thanks, Alistair. That's very good, very thought-provoking, particularly if you just happen to have been awarded a budget to set up an institutional ELN, as I did 2 days ago. So to make sure that whatever we do, we make it so we can migrate in the future, I think, to a potential national service or anything like that. I'd be interested in helping set up. So our next speaker, Gretchen Green, unfortunately, she can't be here in person because she's actually in a different session that's taking place right now. But I have the honour of trying to present a pre-recorded video she made and not lose the audio through this. So if the other speakers, if I fail to do this, if it's inaudible, do let me know. Let's just try. So I should share computer sound, optimize screen sharing for video clip. Now let's see if I can get this to work. Bear with me. No, that's not the right thing. Sorry, I should have done more practice of this. I can see it in my toolbar, but I can't see it in my screen sharing options. Let's go to files. That's not going to help either. Okay, I think what I might do at this point is cut my losses, and we will come back to Gretchen's presentation in a minute. So in which case, I think I shall pass you to Nicole. Nicole, could you introduce yourself? Forgive me if I look a bit absent. I'm going to be trying to work out how Zoom works and how I can share a video, but please get going and do share your screen.
Okay. So do you see it?
Yes.
Do you see my screen?
Yeah, you
yes,
can
we do,
agree.
Gretchen. Sorry. Yeah.
Okay, great.
Nicole.
Okay, so my name is Nicole, and I represent Chemotion ELN. So this is a discipline-specific ELN, and it shows how RDM for chemistry might look like, and includes also tools for related disciplines. And all the projects Chemotion, they're funded by DFG and by the federal state of Baden-Württemberg. Our projects can be found at www.chemotion.net, and you can visit us on YouTube. So we are focusing on 2 main projects. This is an electronic lab notebook and a repository for research data. And we have several other projects in software development, like a Spectra Viewer and Chem Scanner, other NASA software, and those projects contribute to ELN and repository. So 2 main projects, and they deal with documentation of scientific work in the discipline of chemistry, and in particular organic chemistry at the moment, and publication of chemistry research data in the repository. And one main feature is that people may take research data from the ELN, so they do the documentation in the ELN, and then they transfer the data directly to the repository. So that's quite useful, because then you collect the data, you manage the data, you assign the data to other important information, and then after the whole process, after you've collected and edited everything, you just go for a selection of the data and a transfer. You choose the publishing options, and then you submit the data to the repository. This repository is based on the same software basis, so data is interoperable in that case, because you can use the same data in ELN and repository, and you use the same software tools for that. So the visualization and work with the data is possible in ELN and repository. So in principle, if the data is available and well prepared, then it's only a few clicks to open data. So that's the basic principle of it. And we hope that in future, several universities will install the ELN. And then, of course, all contribute also to open data via the Chemotion repository. The ELN, therefore, should be installed at the side of the scientists or in the different universities. And the repository is hosted at the moment at KIT. Coming to the point where we started. So we started at the point where data and documentation was not there at all a few years ago, and a lot of information was lost during that time because people did the documentation as shown in here, especially in Germany and in our labs. It looked like that. So they did everything manually, and there's lab notebooks. And it was hard to do the correlation of the experiment to the data. In the end, that was not clear, and that is a major drawback of the documentation in lab books as shown in here, as you think. And in the end, the problem is that the availability of the data depends strongly on the goodwill of the single scientist. In the end, it means that the scientist has to invest effort to make the data then open and to organize the data in a very good manner, and that's the problem in the end. What we think is quite positive that at the moment, many journals require data availability in repositories. That means that the data has to be organized in a very good manner, and that means in many cases they request also ELNs for the preparation. And in Germany, the code of conduct is launched in a new form, in particular the guideline 12, which describes the needs in documentation. So that's a change right now. And the DFG, so as one of the main funding agencies in Germany, becomes more strict in that case. And that helps, of course, to support ELNs and repositories. This is a typical ELN in chemistry, and that causes a lot of challenges for us. So we, as developer for ELNs and as developers of solutions for documentation, we face then problems like that you have a scheme, as given in here, describing the reaction. It's very important for chemists, so they are very keen on these schemes, and have to be supported by a representation of a scheme very similar to that. And in a current way, they do that in a manual fashion. They use abbreviations like that one or that one, even in the structure. And these abbreviations, including the structure, they have to be converted then into a molecular mass of the molecule, which has to be inserted then in kind of a reaction table and has to be used for further calculations to be able then to do the chemical synthesis. And in addition to that, they need analytics, and they get analytics then out of the devices that they're using. And those analytics have to be correlated to the experiment and the number of the experiment. So these are only two challenges, but I think they are the most important ones for the development of this discipline-specific ELN. And what you see here is a very typical view of our ELN, and it consists of mainly, first of all, two layers or two parts of the UI, and that's on the left-hand side, an organizational layer, where you see the organization in form of collections or projects, as we call them. And you see here kind of LIMS functionality, a very basic one, but it shows how data may enter the ELN and can be visualized in the overview. And these input or this data coming into the ELN can then be assigned via drag and drop to the single experiments. And in the middle of the ELN user interface are lists. These lists can be combined in a modular way. You see here we have a list that's used in that overview, that's summary of samples, and you have the option of summary of reactions. Screens, well plates are there, and what we call a more flexible tool, and it's research plans. And a detailed view of these items, so that means that every entry in this list format has a detailed view that's described then in here on the right hand side, here you see that a typical representation of a chemical documentation is given us here with a scheme and a summary of the reaction table, using the information of the structures as given in here and processed by the ELN. So that's very important, and it's I guess the most important part of the ELN from a chemist's view, because that facilitates the calculations, that facilitates the use of reagents and molecules. So that's the basic part that the people and the students are using. Every item in the list format is then connected to one of the detailed tab or several of them. So that means that in very easy assignment of these parts with those ones in the details tabs is possible. A benefit of this management tool or management way is then that you have the data and they can be processed internally, and you can use the data for the creation of identifiers. So you have the structure, and this is converted internally into an identifier, and this identifier can be used to match the information with other databases. And in that case, that was done with SciFinder. It's one of the most famous search engines that we use in our science, and PubChem as an open database that we use to get information. So what you see in here, a direct connection gives you the result, and that result is then matched into the ELN again. So in principle, that means that all the information is together and can be combined in the list formats. So another point, as I said, is the analytics part, and this is very complicated then if we come to the single scientist and the needs of everyone. But in principle, it means that you have to deal with the data coming from the devices, and in the case is an NMR spectrometer, and the data have to be catched if in a very good way will be on the server of the ELN, but there are other opportunities where we do it that we collect everything on one server, and then we have to read and convert that, and if possible then to convert in open file formats. Here's just two examples for the data that we're using. That's JChem, DX, and NZML as open file formats for NMR and for mass spec. And then we have to visualize the data in the ELN. So that means in the end, the scientist wants that no other software is necessary to visualize the experiments, because otherwise it means more work if you have to store the data and then use other external software to have a look at the data. That in principle is more complicated and therefore not desired. During this process, you have to assign the data then with the experiment, and we do that at this stage. So as soon as the data is available in the ELN and the inbox, the input of the user is necessary, and he or she assigns the data to the experiment that was used to create the data. At the end of this process, then we are requested to enable the analysis of the data, and that's what we're doing for NMR, IR, Raman, and mass spec at the moment. So for those analysis types, we enable within the ELN also the analysis, editing, and then to retrieve the information directly in the ELN. This is one example. So NMR, that's what we've solved for protein NMR and carbon NMR, but unfortunately at the moment only for 1D spectra. But still what you see here is the visualization of the spectra and the analysis that's enabled, including for protein NMR, the multiplicity selection and peak picking. So you retrieve all the information, and then you may take the peak lists and transfer the result. So the typical analysis the chemists are doing directly into the analysis section of the ELN. So a more formal way to describe that, we work in the ELN at the moment with several modules or elements as we describe them. That's samples and reactions, most important for chemists. We have a flexible module for the description of text, tables, images, files, and that can be combined. So these fragments can be combined in a flexible manner and can be exchanged. And now we are working on a generic element. And that means that the user interface and input fields can be defined by the admin of the instance. That means every instance at every university has the option via the admin to define the input fields, to define a single element for this instance. And we hope that in future that the setting for that can be driven by the community. So the idea is to open the formats to the community and then to create an adjacent upload format to be incorporated into the ELN. So in principle, it means what we're missing is the standardization. If we have something like admin-driven element creation, and we want to compensate that in future via the work of the community. This is supported right now by the NFDI for Chem. So the National Research Data Infrastructure in Germany for chemistry. And it's part of Task Area 2. Works closely together with repositories in Task Area 3. And altogether there are 6 task areas dealing with the support of the scientists in research data management. So we have now funding for additional 5 years, as plans to be for 10 years altogether, at least, and hope that we will do a very good job in supporting people driving or hosting their ELN instance at the university, and then being able to transfer data from the devices, from the single lab, then through the ELNs and additional tools to repositories and to open up their data for the public. So I want to thank, of course, the DFG and the Federal State of Baden-Württemberg and many other collaborators, and of course, our development team. So only part of the people in here are the development team, but this is our team at Campus North and campus cells of the KAT. So, and thank you very much for your attention.
Thank you very much. Very interesting to see a proper, particularly a subject-specific kind of ELN in action, and be reminded of some of the complexities and things to consider. Right, I will have another crack at getting Gretchen's video to work now. I'm going to try a different approach, and then I'm going to start the video and then try and link to it.
And if you have any questions in the meantime, please put them in the chat. That's probably an easy way to start collecting them and address them at the end after all the presentations. So.
This looks more positive. Can you see Gretchen's slides? Good. How do I enlarge them, I wonder? Let's not do that. Let's. That looks better. Can you see Gretchen?
Yeah.
Hey everybody at RDA. Sorry I couldn't be with you in person today, but I've pre-recorded a set of slides to share with you some work we're doing at NIST related to electronic lab notebooks. So we're working at NIST in development of laboratory information management systems, and electronic lab notebooks are a part of the research workflow we're developing there. So as part of a case study and working with LIMS, I collaborated with Peter Cornwell in Data Futures, and then on the NIST LIMS side, a few of my collaborators are also listed here as well, June Lau, Ray Plant, and Josh Talon. This case study is based on a use case of research using electron microscopes. These microscopes are used in cross-disciplinary areas for studying materials for a whole bunch of different types of samples, including metals, polymers, even in situ biological materials are used. And the data sets are very diverse. So the data collected can be images, spectral data cubes, many modes of data collection, and the size and the rate in which the data is collected results in small data sets, megabytes, to even terabytes of data. So quite a variety of data captured in these LIMS systems. So this is a really good proving ground for research data management, and the electronic lab notebooks that are used with this research area are, you know, the basis of this case study, and how do we use the ELNs with LIMS. So each step of the data path, including samples, preparation, instrumentation, configuration, what researchers are performing, the microscopy, data collection and experimentation, the archiving of the data, and then, you know, also making sure data is organized in a way where it can be published. So a lot of information is collected. Some of it's added into these electronic lab notebooks along the way, including what the experimental intent is throughout the process. So what we're trying to do is to capture this dark matter that researchers are adding into their ELNs and integrate that into the LIMS for future discovery and access that aid in all of the things that we're striving toward with fair digital objects. This slide shows the workflow for the LIMS system that we're building in this electron microscopy research context. So this big dotted rectangle includes some systems whereby we take sources of information, metadata information, from a scheduling tool. The microscopes themselves collect metadata, whether it's instrumental configuration or information and files that the researchers provided, and then the electronic lab notebooks themselves. We harvest the digital formats of all of these information sets and extract the metadata and associate it together and put it into a classic metadata schema, which we informally call our research dossier. And then that metadata we populate in a metadata repository. And the metadata is a link to all the raw data files, which are stored in a microscope data storage system. And all of this information is accessible in a tool that we develop at NIST that has programmatic interfaces and a user interface, a web user interface. And these interfaces allow researchers to collaborate with other researchers and use tools like Jupyter, HyperSpy. So it's a very, very highly functional overall way of managing data, curating data, and performing analysis. Where the ELNs fit in is, of course, they have a lot of valuable scientific information in them that's captured through this metadata extraction. Like the intent of the experiment, what kind of calibrations, instrumental configurations, notes about analysis. But there are challenges because the ELNs, at least in the case study that we're using based on OneNote, are vendor proprietary in format. So it's a little bit, it's complex, and how do you export the information out of the ELNs, extract metadata? So there's quite a few technical challenges, and we're still wrestling with some. A couple examples here show some variety in the types of data stored in electronic lab notebooks. So on the left-hand side, you see an example of a researcher that captured instrumental configurations in a formal table format. And then on the right side, this ELN notebook shows hand-drawn electron microscope lens configurations and apertures that were also used for the experimental setup. What this case study took advantage of was making use of the concept of doing annotation. So while we can extract metadata out of the ELNs and put it into a digitally digestible format, machine readable, that's fairly complex and a work in progress, but we have some services and tools that allow us to take these digital ELNs and annotate content for these ELNs that will further make the ELN information discoverable and associate it with other aspects of research. So here's a couple examples of what we mean by annotation. And the ELN view that we're showing on the left, where we have a bunch of text describing what's going on with the research, an instrumental configuration, and then there's a table. We know that this is a really important configuration for the microscope. So we mark it as an annotation of type transcription. And we're doing this through a tool, which I'll describe, or at least, tell you a little bit more about in the coming slide. And then another form of annotation that we demonstrate here is that not only do you want to be able to annotate specific artifacts related to an ELN to make it discoverable, but you may want to do things like annotate and capture persistent identifiers of the people that are actually performing the annotations, and include things like work IDs, which are persistent identifiers for people. So here it shows an example of I perform this annotation of an instrumental configuration, and then I also capture through annotation the work ID or persistent identifier for the annotator. So what are we doing with this annotation? So the tool that I alluded to in the previous slide was, in collaboration with Data Futures, there is a service and repository system called Frizo that we use for this case study with the ELNs. And what we do is we take the notebook data, digital data, and convert it into a format that is annotatable and can be saved. And this tool Frizo actually converts it into a standard W3C format called the Web Annotation Data Model, or WADM for short. And this also conforms with some other work that's going on with the image interoperability framework and standards-based annotations. This format is based on OpenJSON formats and can serve as another means for not only annotating specific content in ELNs, but we can also use it to annotate research activities, stages of research, and processes, such, to include more provenance like metadata about the research itself and in relation to ELNs. So where are we with this? We demonstrated some concepts here, and how do you manage very heterogeneous electronic lab notebook data using annotation. And we think that there is a lot of benefit for integrating these WADM-like ELN datasets into a shared data repository for discovery and mining of research content. It's continuing to be a work in progress. How do we extract all the content from an ELN? There's some technical challenges, and this work is continuing at NIST and has made progress beyond this case study. We're happy to talk to you about it. The collaborations involved here include, beyond Data Futures and NIST and RDA, there's other groups that are involved in the Data Futures effort. And the Frizo project as well. So I've listed a few other aspects to this, and just quick mention of the last bullet is that with this annotation of ELN metadata and putting it into a standard machine readable format, it does lend to supporting machine learning capabilities for doing this in an automatic way. So we do see this as contributing toward our overall goals in RDA, and using ELNs to support discovery and interoperability. Annotation is one method that we see as supporting these efforts and moving forward. And if you're interested in talking more about it, please reach out to the Research Data and Engineering Interest Group, myself, or Peter Cornwell. We're happy and look forward to talking to you more about it. Thank you for listening. Enjoy the rest of RDA.
Thank you very much, Gretchen, who's speaking live in a parallel session at the moment, but thought that it raised some interesting ideas about how you can maybe start to integrate ELNs with other systems and bits of infrastructure in an institutional setting. Right, that leaves us as the final of our main scheduled speakers this evening, this afternoon, this morning, the middle of the night, is David Drake, who's joining the conference. Now, David's going to give a perspective from industry. David works for AstraZeneca. So, David, if you'd like to introduce yourself and your topic, please. And don't forget to share your screen.
Okay. First of all, can you hear me okay?
Yep, loud and clear.
Okay, and can you see the slide?
Yes.
Excellent. All right, well, we're good. Well, thank you very much for the invitation to speak to you today. It was a pleasure to be here. So my name is David Drake. I'm the Drug Discovery Capability Lead within R&D IT at AstraZeneca. Prior to that role, I was the Domain and Enterprise Architect for early science for 6 years. And in the dim and distant past, a research chemist. So I was really interested to see Nicole's notebook. It's very good. So today I'd like to share some perspectives on the implementation, adoption and utilization of electronic laboratory notebooks within a pharma research setting. So hopefully touching on some of the challenges that you've already mentioned associated with integration, data access and reuse. And also look a little bit into the future of how ELNs need to adapt to meet evolving scientific needs and how we can learn from our lessons of the past. So that's top topic. Hopefully, there we go. So I'm going to start by giving you a little bit of background on our ELN journey from an AstraZeneca perspective and its role within our research architecture. Look at how things have evolved over the years, and then wrap up with where our focus is now and where we see the future going. So, potted history. We first embarked on our search for an ELN 17 years ago. The primary driver was the replacement of paper notebooks. And the benefits of doing so really were looking on efficiency and productivity gains for the scientist. So reducing re-entry by being able to clone previous experiments and reuse them, and also functionality like built-in calculations to really optimize when you're doing molarity calculations or yield calculations, just to have it very, very quick. The other big driver and big concern, obviously, at that time was continued IP protection, paper being the gold standard. So there was quite a lot of discussion with the lawyers around how whether the electronic record was good enough. Obviously, that's way in the past now, and I think we're way beyond that. The drive first came from our pharmaceutical development function, where the role of ELN was more about capturing their methods. So it's quite structured, quite a rigid template, which they then filled in to make sure they had all the results captured. From medicinal chemistry, which is the one I was involved in, we followed along with a more traditional notebook interface that really mirrored the paper version. So the one that you saw in Nicole's slide looked very much like that, even in electronic format, and also mirrored the experimental workflow. Finally, of course, biology, not wanting to miss out, also embarked on an ELN implementation, but they didn't have such a structured format for their data capture. And as such, what it's ended up being is largely a collation of documents associated with an experiment. So from an architecture perspective, I won't go into too much detail. I don't know how much you want me to go into. I was taking it from the title of the session. So from an architecture perspective, all these are installed on premise. So with traditional 3-tier architecture with Oracle databases underneath, application server and thick client. The result of that is obviously that your data is very much siloed within an application. Due to the intellectual property associated with the experiments, and as I said, the struggle for legal to accept the move away from paper notebooks, the resilience of the system needed to be ensured through full disaster recovery. And as you can see, the diagram, a bit small on the right-hand side, shows that what we did was to have near real-time mirroring of the data as it was entered, to the disaster recovery, so syncing that in real time. And then every couple of months, we took a full copy of the database as a backup. The ELN we chose also had an offline capability, so should you suffer network connectivity failure, you could continue to work. That was very important to the scientists. They couldn't be beholden to having networks are available all the time. And then it resyncs automatically when you connect. So it was only the MedChem ELN at the point of implementation that had interfaces to external systems, because that's the one that we implemented very workflow orientated. The scientists naturally wanted the ELN to seamlessly connect with things like reagent inventory, compound registration, and those were all delivered via fairly basic web services to do that. So it wasn't long, as you can imagine, before things changed and enhancements were requested. So we had to evolve and improve things over time. So a really thorough investigation and evaluation went into choosing the ELN as an experiment data capture tool. However, the ability to get the data out had been largely overlooked. It was soon very evident that the search capabilities within the tools themselves were suboptimal. So although you could build Oracle views to create access to the data from another system, it then became apparent that the quality and uniformity of the data was lacking. So a project was then undertaken with an external content provider, so we worked with Elsevier to provide a combined reaction database, which included our in-house reactions from both the MedChem and the PharmDev ELN, and the curated literature content that they managed. So the data was extracted, it was mapped, cleaned, which was quite an extensive process given the quality, and then mapped to a unified data model, and then provided to Elsevier, who merged it with their own content data and then delivered it back to us through their web portal interface. The benefit of there being, obviously, that we could then see both our in-house reactions alongside literature reactions and have the best of both worlds in that. So it was also an important milestone, I believe, in demonstrating the ability to separate the data captured, the data capture user interface, so the notebook itself, from the ability to query and explore the data. So this is alluding very much to where Alistair was heading, I believe. Sorry, I missed a bit. Sorry, there's a bit more on that. So we also had at some point post implementation a change in R&D strategy. So we had a large outsourcing in this initiative, and we needed to access the ELN by external partners. So this again is a common thing, especially if you're considering having a notebook which is national or shared across institutions. The architecture we had at the time, and obviously things have moved on considerably, which I'll touch on in a minute, was to just provide them with a Citrix solution. So they accessed it through a Citrix client. We maintained a central experiment repository, and via adequate access controls, the partner could write and enter their own records, and AstraZeneca could see the full set of information. In the biology world, as I mentioned, the use of ELN as a document repository had resulted in quite a significant overhead for scientists, and to their point of view, very little benefit. They created an experiment and then stuck their Excel spreadsheets in it. So what we've done in that sense, in the short term, or medium term, I should say, is to do robotic process automation, so RPA, to facilitate the upload of supplementary data. It's almost like a fix rather than a solution, I believe, in that sense. So science doesn't stand still, as I'm sure you all know, and new data types, new modalities in terms of drug substances, for example, and new attributes associated with those, plus new and automated workflows mean that it's time for a solution refresh, and that's currently what we are embarking upon. I can give you some insight into some of the considerations that we're thinking about. So on the left-hand side, you can see where we were. I've covered most of this, so I won't repeat it. But what we need to move to is something that includes much more focus on data. So there's been a big initiative within the company and across many organizations around the value of data as an asset, and really to get the most out of it, maximize it, reuse it for machine learning, AI, and all that sort of good analytic stuff. So that has been a big focus of the new ELN, and learning the lessons from the past. We don't want a solution that just locks the data away and doesn't really benefit anybody. So providing that knowledge sharing across the enterprise, making the data available for all, and continuing to operate in a collaborative environment is really important. We also have different, as I mentioned, different modalities of compounds to deal with. So where they have the extensibility of the format and data capture needs to be there. And we also need to work in a more automated and parallel way, because that's part of the process that we do today. So we know, but we knew from the past, and again, the MedChem ELN was a good example, that the most satisfied users were those that benefited from workflow efficiencies. So, where as I told you, the bioscientists were pretty unhappy because they didn't see the point. The chemists have been pretty happy on the whole with what they've been given and the efficiencies it provides them. So that really is a very important adoption factor for any new ELN we're going to introduce. So that future view, last bit. What's the learning? So what learning do we have that will influence our future ELN strategy? So first, the market's changed as well. So as I say, the vendors we had originally were all on-premise installations. The offerings now really move to a technology leap to majority advocating externally hosted software as a service solutions. So you mentioned service right at the beginning of the session today. So that service is being offered by third-party suppliers. And it's not so far-fetched options as it would have been back in 2004, where the IP lawyers would have had an absolute fit. With many, as I'm sure you have, cloud-hosted solutions with some vendor-managed, others in a virtual private cloud. The advantage of that sort of solution, cloud-hosted, is clear for partner access, as well as obviously the inherent infrastructure redundancy and data backup that you get in that environment. The main factor for us to consider from an ELN and from a workflow point of perspective is the integrations. So are they on-prem instruments that then have to funnel all their data up to the cloud, or are they legacy systems with APIs that don't really work so well, and therefore the performance of the overall system and workflow is going to be poor? So that's something we're going to be looking into and keeping a very close eye on. So the cleanup required on the ELN data to make it reusable has highlighted the importance of including standard vocabularies and ontologies at the point of data capture. So really interested to hear Gretchen's talk. Integration of reference data with the new ELN is something we'll be looking into. The separation of ELN functionality from data layer, this touches on what Alistair was saying and hopefully supports what he was saying, is another premise we intend to apply. So if you look at this diagram, if it's visible enough, in the purple row here, we've got, from a scientist's perspective, the ELN records the work they're doing, so it's useful in that sense. It adds additional value by having those functionality to increase their productivity, the calculations, the cloning, etc. But also, if it's maximum value, if it's a pivotal point of their workflow and really drives it forward, they're very happy. Underpinning that is the data that they're capturing. Obviously, the data flow and integrations that make that data move along with the workflow and available at the end of the day for analytics and insights, and the ability to search it. So what we're doing is looking to separate the ELN functionality from the data foundation, and having that separation can do what Alistair was describing in terms of modular interfaces and different templates for different users with a solid foundation and data model underneath. So we tailor the user interface and support the workflow with the data operating and exchanging independently and extensively underneath. That leads us on to, or starts to impinge upon whatever you can find in terms of platform offerings, where the ELN is just one component of integrated suite. So it could include registration, it could include reagent inventory, it could include testing suite, for example. The advantage of those is it reduces the amount of inter-system integrations that we would have to do as an organization to support the workflow. The challenge, though, is the existing software estate that we have will be significantly disrupted with such a solution. So my final point, and it's a thought for the future, maybe we can debated a bit, is the feedback loop. So we've got the data now in our nice data layer, and we've got the ability to exploit that data for analytics and insight. So where can we use that machine learning and modeling in the ELNs of the future? So the insight-enabled ELN, as I've termed it there, will provide us suggestions at the point of data capture. So as you saw in Nicole's diagram, you've got the chemical scheme, for example. So if entering a chemical reaction in that box, the ELN would trigger a set of background models that will present back to the scientists optimum reaction conditions, alternative retrosynthetic routes with tractability predictions, warnings of risks and hazards associated with the experiment of that type or using that combination of reagents. So the list goes on, really. The value back to the scientist is enhanced significantly with the data that they have so diligently captured. And that, again, is one of the answers to that very question, is what's in it for me, when they are obliged, should we say, to use an ELN to capture their research, so they actually see the value. I think that was my final point. So thank you very much for listening. I hope it was of interest to you.
Brilliant. Thank you very much, Dave. It was, I thought, a really good, useful set of talks that kind of had various points of contact between them, which are very interesting. It's always good when I think it works out like that. So we've got about 15 minutes for questions and communication before I pass over to Keith, who will end the session with some thoughts and a couple of minutes of kind of interest group admin. So I've just been starting to take a look at some of the questions that have been coming through on the chat. So maybe if we start with these, and then I'll move on and ask people to put their virtual hands up and come to people. So we have a question from Maria Schatz to everyone, some more than others, I suspect. I'd like to hear insights and experiences with physical implementation of ELN in the labs on the bench. What devices are you using to enter the data and notes? Anyone want to address that, the actual physical conditions? Nicole, let's go for Nicole first, and then we'll come to Al.
So we have now some experiences with tablets. So that's what we tried and practiced that a bit. And I was not that convinced at the beginning, but the students like it. So I think that has some limitations, in particular with drawing structures in an ELN, but still for just giving some data input that's sufficient and that fits.
Al?
So I was going to observe that the interests of researchers in our institute, people have been using phones and tablets on the wet benches, computers beside those wet benches. But a recent inquiry has prompted interest in voice recognition. And in particular, this came about because one of our researchers broke her arm. She wanted to be able to speak into her notebook in Spanish, but have the notebook write in English. It seems like the world's not quite ready for that yet. It's a tall order, but it would be great. And I think there's that generally voice recognition software has come on a long way. The challenge was always about how to go back into a paragraph that you have already dictated and make amendments to it. Now I think that's becoming easier. So yeah, I think that's where we could make big gains.
So I could just add to that. So that's definitely something we're looking at for our new notebooks and for lab working in general, voice working and tablets. So originally, when we put the ELN in, we had to have a separate office and lab set up. So we used a remote terminal to access the ELN in the lab, and then that was mirrored into the office environment. So if you left the lab, you still had your experiment open. So that's how we managed that setup. But for the future, is looking much more that you'll take a device into the lab, be it a voice enabled device or a tablet.
Yes, we're seeing that a lot of UCL, a lot of our lab groups are taking in tablets. Nicole, you wanted to add something?
Just a question. So we were interested in that as well. So recording voices and speech recognition for that. But I was wondering whether that works in a lab environment with a lot of noise. So devices and pumps and everything. It's going to be difficult, I guess. But I don't know. We've never checked that. And another question would be whether the redirect to the right experiment is easy, because in principle, if I'm thinking about how I'm using the ELN at the moment, I just have to know well, what reaction or reaction number I'm using and what I have to find in the ELN, and that's faster if I'm in front of a tablet or computer. If I have to search that via voice, I don't know how that should work or how that could work. Do you have experiences in that?
Yep. So we're only doing trials. We haven't rolled out a full voice-enabled lab yet, but it does seem to operate okay in the presence of quite a high background noise. It does have the other challenge is the lexicon, because obviously if we're talking at it in terms of chemical compounds and chemical names, its normal dictionary wouldn't pick those up, so you have to have that needs to be built into it. And it's normally intelligent enough to reference the notebook you wish to make an entry into. What it does do is it captures the annotation in a like a holding area, and then it's available to review to make sure it hasn't made any obvious mistakes before you actually put it into the ELN. So it's actually a two-step process. It's not writing straight into the ELN at this point in time.
Great, let's move on to another question. So Al has a question for Nicole. Thanks for your talk. I was struck by how complex chemistry notebook products seem to be, but they've been around for a while. Do they share a common standard structure that would permit you to export your data and import it into another product? Or is the exported data useful as a text-only archive?
So yes, I guess there's some information that can be used in every chemistry ELN, like the identifiers that are commonly used, so SMILE, small files, INCHI keys, and so on, or SDF format that can be used to exchange data, and of course the descriptions and perhaps many more information, but still I'm not aware of a standardized way to exchange data from one chemistry ELN into another one. But perhaps it's also a problem of many commercial products. I don't know whether that's the reason why I think that some, at least, of the suppliers of ELNs are not that interested in exchange formats. So because then they lose their users more or less, and that's probably one problem that we see.
Yeah, one of the things that as we look at ELNs, one of our top requirements is that we don't want to get trapped into a particular product for the university. So the ability to export and import data in a usable way in a common format is going to be very important. So I haven't really started this work yet, but it's something I can maybe report back on in a year or so's time. Al, I noticed you had your hand up as well. Oh, you're on mute.
Apologies. No, sorry, I really just wanted to simplify the question and ask if anyone had strategies for the event of a company like Chemotion, for example, folding and the products becoming unsupported or simply breaking. Would the export tools that are available in the product just now allow you to create anything that would be useful as an archive, as you just punctuate everything you've done up until now and start a new chapter with a new product? Would the previous data still be useful?
So at the moment, we support an exit strategy for all data that's covered by the ELN, and it's a JSON format, so readable in principle, and then has to be matched to the input fields that are available for another ELN, as an example. There are other file formats that we support, and also kind of Word export, which I think is not that useful in that case, but still there are a lot of options to export data and to re-import them again, probably the JSON format and the table format that we offer are the most suitable ones. Yeah, but still, what we need is kind of standardized approach to match all the data to another ELN and standardization, and that's at the moment missing. There is, for example, I know the approach of the UDM initiative of the Pistoia Alliance, and they're working on a standardized format, and I guess some of the other key players as well. And that's what we want to do in principle. We want to wait for an approach that's supported by the players or the largest players, and then adapt the system to that.
Thank you.
Let me unmute. So just looking on to some of the other questions. So there's a question about community schemas. Question from Bjorn Brotz. Do you think a common modular standard for the underlying data model for the zoo of existing ELNs out there, or do you think of a new tool? That was a question addressed to Alistair. So you described your vision of a modular notebook. Do you think a common modular standard is?
I think it would have to be, well, I think it should be defined by the community. A whole new set of standards should be created by the community, because clearly current vendors have failed to come to an agreement on a common set of standards, and this is what prevents portability of data between all the products. And I think this, it seems like it's something I lobbied for many years ago when we were talking to vendors, that they could open up, if they would collaborate with one another and agree on a set of standards, they could open up a much larger market, and take away a lot of the obstacles that are preventing people from buying into their products just now. But it hasn't happened, and I think we can control of that and basically.
I think you might be breaking up a bit, Alistair, either that or I am. Everyone else seems to be sort of. I'm wondering, I mean, is this actually a job for RDA? I mean, RDA is the kind of international body that can play a role in forging standards and encouraging private sector companies to stick to community agreed standards. So is this something that we should be looking to do, perhaps not with this group, because the central aim of this group is a bit different, but is this something that we should, interested parties, to be thinking of setting up a separate RDA interest group in perhaps in forthcoming conferences? I think we may. Oh no, Hal's back. I don't know if you caught any of that.
I think I would like to see that what you described there. I think we discussed it before. These missing exchange format that is hindering interoperability between the different ELNs that are out there, and also what Alistair was saying earlier, that points all into this direction, that we should have something like a common exchange format. It's also I had this experience that I had contact with a number of groups in Germany that are all very much bound to one particular solution because it's fitting to their individual situation, but they would love to have still some kind of interoperability between themselves. So this sounds pretty much like that. Maybe RDA could be active here in finding something.
Well, I might post a message around and see if there's much interest in getting such a kind of group together. I think there might be something that the RDA Secretariat might be interested. I'm not aware of anything like this that exists already. I don't know if anyone else in the room is aware of a group in the RDA that's already looking at these kind of issues relating to ELNs.
James, there is a chemistry data interest group, I think, in RDA. I don't know if anybody is present, so anybody here is present from that interest group. Nicole? You're muted.
You're on mute, Nicole.
Sorry, at least I'm part of it, yeah. But yeah, I don't know of any initiative in that direction within the chemistry research interest group.
Okay, well, maybe it might be a good idea if a few of us get in touch after this session and just see if there's going to be broader interest in doing such a thing. I have to say, I'm not an ELN person myself. You'll know a lot more about this than I do, so I'm probably not the right kind of person to kind of co-chair any such group. It seems like something that we should follow up and have a look at. Now, in terms of following up and having a look at things, I think we'll have to stop the questions there because I'm aware we've only got 6 minutes left of this session by my computer's clock. I think is just about right. So before we all depart and head our separate ways and look at which sessions we want to attend later, I'm going to pass it over to Keith.
Thanks, James. First of all, big thank you to all the presenters. That was a really interesting overview of a range of different perspectives, but a lot of overlap and connections there. So it was great to see those patterns. I think one of the things, yeah, we just see that in the chat now too. Our ELNs are not just for chemistry. So yes, that is a very good point. So when we talk about interoperability and connecting up and allow exchange between ELNs and outputs from ELNs, there's a big challenge there because you're not, chemistry is a broad field in itself, but outside of that, there's a whole range of other disciplines. And how do you enable exchange between all those different disciplines? So I think there's quite a complicated challenge there. Anyway, back to the interest group as a whole. The RDARI interest group is not just focused on electronic lab notebooks. We are more broadly interested in research data, sorry, in infrastructures to support research data or architectures to support research data in research institutions. So we'll continue our work in upcoming plenaries and activities focusing on other activities. Please put any information you want to add into the collaborative notes. I'll copy and paste the chat into there too, so that we have a record of that, so you can go back and have a look at what was discussed, and hopefully please add some useful links and things like that. If there are any topics you'd like to covered in future interest group meetings, please let us know. Please join the interest group too. If you can add just yes to the final column, we can add you, or just join the interest group is probably the best route. You can stay in touch of the activities we are doing and what we will be doing into the future. One thing that's happened is sadly Ville had to leave the group as a co-chair. It was great to have Ville as a co-chair, but that means that it's just James and myself at present, and we'd be very interested in having another co-chair to join us and to strengthen the group. So if there are any volunteers here, that would be great to know. So either speak up now or approach us outside of this meeting, and we'd be very happy to have a chat about us joining the group. And especially if there's anybody from the US here, that would also be good, because then we have nice representation from Europe, Australia, and the US. So any suggestions for upcoming interest group meetings? Any topics that you think would be of interest to cover? Alistair?
I was just going to say, one of the things that I'm becoming interested in is that we've always had this approach that the institution should try to provide something to prevent chaos at individual level. And I'm wondering if that's still true. Even in the context of our discussion today, it's been interesting to think about the individuals who are using their own products and doing their own thing and being very successful and supporting themselves, where the institutions have failed to provide a single common system that suits everybody. Yeah, I guess that's what I'm interested in, whether we should be designing infrastructure for large communities or allowing individuals to design their own systems now that so much of it is provided by third-party cloud services. I think the whole landscape is changing in a very interesting way.
I think I'd second that. So if we can have a meeting on like centralized infrastructures, that would probably not be too bad, because also this involves a lot of AAI aspects and so on. So it basically gets more difficult from the rights perspective, maybe, but that's also a challenge. And hearing experiences from that, maybe it's one idea for the next time.
Sounds good to me. I think what we'll do is, if we circulate, if you've got your name and email address down in the collaborative notes, we can certainly get in touch with everyone here and just encourage people to join the RDARI group more broadly. Do you want to say anything else, Keith?
No, it's just an observation on that. I think it's a really interesting angle, that question about institutional versus discipline-specific needs, and how do you marry those up, and do you come up with central solutions, or do you go with different solutions? But how does that fit in with institutional needs and institutional infrastructure? So
yeah, certainly bang on topic. So good suggestion. Okay, the time is 6:30. So, well, I'm where I am, it's 6:30. Where you are, I mean, and where you are, Keith, I guess it's probably about 6:30 in the morning. So
5:30 in the morning. So
5:30 in the morning. You're not far off. But I think we should probably wrap this up. I would also like to thank all our speakers. They were really good, interesting perspectives. I'd like to thank everyone that's attended. I hope that you've got some perspectives on things, maybe learned something new, got an idea, something to follow up. Yeah, do put your email address in the collective notes, and we will send you further information in due course. And do please, if you want to be on the organising committee, do join us. The more of us there are, the smaller each person's workload is to try and set these things up and get them running. Even if you don't want to become a co-chair, we always have a larger group of people involved in our meetings between plenaries who come up with suggestions and ideas and think speakers and so forth. So I'd like to thank everyone that's been involved in our meetings and the running up to this plenary as well. I can see a few of you here, I think Stefan and Rosanna and so forth. So it's always, these things are always a collaborative endeavour. We all do like to work together and try and bring in good. So yeah, I think it's probably goodbye from the co-chairs, and thanks to our speakers and thanks to everyone who's attended.
thank you all.
Thanks everyone. Much. See you soon. Bye-bye.
Bye.
Thank you.
Nice to see you.
Good to see you all.
Thank you. Bye-bye.